What is going on, everybody? Thank you to the folks that have been here all day. This is conversation number 2 of day 2 of 2022 NYC AgTech Week. And for this conversation, I could not be more excited to bring together a panel of entrepreneurs, experts, and space farmers to talk about a little bit more of a fun moonshotty idea that's part of science fiction lexicon, but is actually being done and thought about today by NASA and a lot of other organizations. And so in this topic, we're going to look at space farming and the reality and potential of actually farming plants in space at a production level, and actually feeding people in space, and start to have hopefully a really maybe technical, maybe theoretical conversation. And then we're going to bring it back and start to see how these applications of space farming are really being used by people here on Earth to think about challenges in a new way. And so with that, I'm excited to pass it forward, and we're going to do a quick introduction for all of our panelists, about 2 to 3 minutes, who you are, what you're working on. And Tej, why don't you go first?
Hey, everyone. Can you hear me okay? Awesome. Dan, great to see you. Thank you for inviting me to join. Dan and I know each other for a very long time from the startup world and have a discovered joint passion about space. I'm the Chief Revenue Officer of Axiom Space. Axiom's building the first commercial space station, but the next space station after the ISS. And our modules will start going up at the end of 2024. Our missions have already started going up. Our first mission went up in April. And my job as Chief Revenue Officer is to go find customers and figure out the future business here, which is mostly around governments, corporations, and private individuals. Thank you.
Awesome. Christine.
Hi, my name is Christine Escobar, and I am Vice President of a very small company in Boulder, Colorado called SpaceLab Technologies. And what we do at SpaceLab is research and develop technology that's needed for people to live and work in space sustainably, so that we can explore further and we can stay longer when we get there. That includes a wide variety of technologies like science instruments. We work on life support systems, whether they be biological life support or like physical life support systems, communications and data handling kind of technology, and even space agriculture. So we think of ourselves as space habitat outfitters at SpaceLab, and we were founded in 2016 and have been pretty lucky and successful in receiving many R&D awards from NASA to develop new technologies, especially in the area of space ag. And that includes a system that we're currently developing for growing duckweed plants in microgravity, actually called microgravity lily pond, as well as many other projects that we have on the books. So thanks for having me.
Thank you, Christine. Daniel, why don't we talk about what you're working on?
Sure. So Dr. Daniel Tompkins, I've got a degree in plant medicine from University of Florida, lifelong passion in agricultural systems and environmental systems. And I'm kind of unique, I think, in this arena, because I came into this very much a skeptic in saying, how would you possibly have sustainable agriculture off Earth? And that was a few years ago, and came across a process that using bioplastic, actually, that may be keystone to making this all work. So kind of the space skeptic, but eternal optimist, and excited to be on.
Awesome. Thank you. Stephen, you're in Florida, right? Another US guy?
Yep. So hey everyone, good to be here. My name is Stephen Lantin. I'm a 4th year PhD student in the Ag and Bioengineering department at the University of Florida. I also am very fortunate enough to have been selected as a NASA Space Technology graduate researcher. And what that is it's a fellowship that lets me work at NASA. So over the past couple years or so, I've sort of helped out with some of the projects down at the Kennedy Space Center. I was working in Greenworks and the plant processing areas there. And I also do a little bit of work for the Johnson Space Center, working on more broadly life support systems. So, yeah, happy to be here.
Awesome. Thank you. I mean, this is a super qualified panel to talk about space farming. And so, one thing I will say is I have a couple questions for everybody. If any other panelist has an answer or would like to continue the conversation, by all means, please, after one panelist is done responding, please continue that, because I think these conversations are awesome when they're organic. And so I think, Christine, maybe this is an interesting question for you and maybe Stephen as well, but NASA's already growing plants in space. Can we talk about what is happening now and what the current success or failure is of plants actually in space?
I'll take that one, Stephen.
Sure.
So I would say that, yes, NASA is growing plants in space currently, but I always like to remind folks that NASA's been growing plants, as well as other space agencies have been doing research in space plant production for decades, honestly, starting since the 1950s. And there has been great strides over those 7 decades of research and development, from ground-based test facilities and studying what crops would work well for producing food for supporting a crew diet in space. How do we deliver water in microgravity? How do we make a growth chamber to grow a plant in a very, very limited volume where we have limited power and resources, and it's very expensive to bring mass up into this small spacecraft. How do we do all of those things? And over many years, there's been a lot of experiments in Earth orbit, on space stations like the ISS, on Mir, on the space shuttle, showing that, yeah, we actually can grow a plant in this environment. We can successfully deliver water to it and feed it. It gets a little confused in microgravity, so there's some strange effects that we've folks at NASA have studied for many years, trying to understand better how high radiation and microgravity might affect its growth and its morphology. We've studied how reduced pressure affects plants, and sometimes in spacecrafts you might not have the same pressure that you have on Earth. How to monitor and know when the plant's not happy, and monitor for stress, and studying things like gas exchange. Actually, one really great example of something we've learned through growth studies in space is ethylene production. That there's certain volatiles and things that a plant might produce that you wouldn't even realize, maybe not realize is going on in terrestrial agriculture until you stick this plant in a very small box, and discover that there's some very dynamic gas exchange and other processes going on. So there have been many studies showing you can germinate, you can propagate, you can grow, you can even eat the plants. And recently on the ISS, there have been successful harvests of various leafy greens and bok choy. They've grown radishes. So yeah, there's been a lot of work and a lot of excitement in this field for many years. Stephen, what have I missed?
Yeah, you had a great overview. Yeah, but just chiming in on what Chris said, when we talk about growing plants in space, I think, and Chris is actually very good at this, is designing the actual systems to adapt to the space flight environment, right? One thing that really affects growing plants in space is obviously the lack of strong convection and gravity, right? So when we look at designing things, we can't necessarily use the same irrigation systems as we do on Earth, as much as we would like to. And as well as, a lot of different types of technological innovations have come out of this. So, over the years, over the decades even, NASA and a lot of other organizations, a lot of the governmental organizations around the world actually have really been trying to tackle this opportunity as we sort of move toward the moon and to Mars.
Cool. That's awesome. Thank you. Tej, I just take it from a different perspective. I think the government has been sounding like they've been doing research. I think from a business perspective and looking at it from the private sector, does growing food in space make economic sense? Is it something that you could forecast, maybe not in this decade, but into the future, where it would be something that's valuable to think about in a for-profit enterprise?
Yeah, so it's a great question. So let me rephrase your question, or answer it in parts actually. So will we be able to forecast? Are we able to forecast the value this will have? No, right now, absolutely not. But I think we will this decade for sure. I don't think this is a far off future. What that's going to look like, I have no idea, and nor would I pretend to. And when you asked me to join this panel, I was like, why would you want me? I don't really have the science background of it, but this question actually explains a lot of it to me. I'm very confident we're going to figure it out, right? And when we figure it out, that includes the scientific component, it includes the economic component, and it includes the cultural component. So there's a couple of elements here. One is we're in this very interesting time in the commercialization of space, where we haven't fully figured out how to survive in space. We're almost there, but we on the commercial side are trying to figure out how we live in space. And living doesn't mean surviving. It's everything that comes with thriving our civilization elsewhere. So obviously, I mean, personally, I believe growing food, being able to have space farming is very important to the survival and the thriving of our species off planet. Does it make economic sense? In the beginning, it probably won't, just like all of human spaceflight and presence in low Earth orbit. But if you looked at the internet 25 years ago, it didn't make economic sense at all. And we now all believe the internet is free. We all think we're using this for free right now on these phenomenal phones and connectivity. But companies like Google and Amazon invested billions upon billions of dollars in infrastructure in the 90s. And they do every year now, and figured out a way, and they had to do that to support their own business. It wasn't scalable, it wasn't feasible. But then they learned quickly how to fractionalize that and make it available for everyone else. And all of a sudden now these are gigantic transformative economies of scale. And I'm pretty confident we'll figure that out for space and space farming as well.
Well, I think you actually brought up an interesting point. And as a follow-on, do plants, maybe not in the context of farms, have a role in living off-site? And if so, does the technology, I mean, I would assume that the technology that they're developing for farming could be environmental technology long-term. Does that correspond?
I'll quickly say something, and I'll hand it off to the people who actually know what they're talking about, because you're gonna keep hearing me come back to I don't know, but I'm confident we're gonna figure it out. And that's the startup founder in me. That's the person that you met first, Dan. Yes, it does correspond, and I think it corresponds in a couple of ways. Like, first of all, I forget who said it. I don't know if it was Stephen or Christine, but things that we take for granted that are pretty simple here, right? And you just change a few factors, not even forget microgravity, that changes like dimensions, but just put it in a smaller box and all of a sudden you discover something that you didn't know about the features of that plant or that species. What we're going to discover, first of all, just to survive and thrive up there, is going to create a whole bunch of intellectual property, right? That might be technology, that might be really tasty tomatoes, it might be whatever. It's going to create a lot of value. A lot of that value will come back and be experienced and utilized here on Earth, but a lot of it will be in the space economy as well. So to quickly answer your question, yeah, I do think it vibes with what I'm saying.
Awesome, thank you. Daniel, I did not forget about you, and I think this is a perfect time to talk about some of what you've been working on, which is a fundamental rethinking of kind of what a farm could be in space, right? And I think you mentioned bioplastics, and I'll hand it off to you to kind of explain what a new idea could look like.
Sure. So I think traditionally, right, space technology has been developed, and there's been a lot of, as we push these barriers right forward, there's a lot of spin-off technologies. It's okay, we're doing this in a small box or in a different environment. We're going to discover new things by operating in a new way. I think the opportunity here, though, that's missed is what I'm just going to coin right now is spin-out technologies. Is how do you do this completely outside the loop of Earth's resources? And the space industry has a hard time communicating that, oh, why are we spending all this money in space when we could be spending it here on Earth? And really, for me, it's about how do you sustain independent of Earth's natural resources, all the ecological services that gives us clean air, clean drinking water. How do you bootstrap a civilization from a can is a phenomenally spin out technology that may have no spin-off technologies, may not be iterative, is it may be just totally disruptive. And I think, that geopolitically has a huge take-home message, because it's, hey, we can thrive anywhere. We don't have to fight over resources here on Earth. Look at what we can do in space. And as much as we went to the moon 50 years ago, are we really breaking any new technological barriers to go there again? But if we go there to stay, that's going to be the biggest, and staying is like food number 101, right? Agriculture traditionally has supplied us with building materials. It's provided us with food. It's provided us with clothing. How do we do all these things in space? How do we get clean air, clean drinking water, building materials? How do we use biology that has been historically so centric to our survival? How do we do that and create systems that function to provide this for us? So I'll phrase it that way. As far as I think there's two categories of technology here: spin out, spin off, kind of the traditional spin off. Oh, this is something new. And then the spin out, which is just totally outside the box, space settlement, which I think has huge ramifications. And it's not so much, oh, abandoning Earth. It's a real simple message. How do we become less of an extractive? How do we instantly become post-oil? You want to talk about instantly post-oil agriculture? Bam, space is it, because you're by default post-oil. So there's I think a lot of different things, from nitrogen fixation. 1 to 2% of all our energy is used just to make nitrogen fertilizers here on Earth. And no one thinks of that. No one thinks, oh yeah, 1 to 2% of my annual salary goes to nitrogen fixation, right? There's so many disconnects with the general population. When 1% of the population is working in agriculture and 99% of it isn't, you just have these big gaps in needs. I think that solving through the filter of space kind of is a really potentially paradigm shifting.
That's awesome. So, one of the things that is we talked about yesterday throughout the day is that agriculture is really a lot of moving water, right? And water is ultimately what makes up a lot of vegetables. And so, outside of a water source that's extraneous to Earth, is it ever going to be realistic to sustainably have farms without water? I mean, or is it even possible? Is it even worth thinking about? Because without water, is civilization possible? And so that's kind of that first step that's important to everything else.
Yeah, I can sort of speak to that. So when we talk about, growing plants in space, a big sort of topic that comes up is life support systems. And that's sort of talking about, what is actually necessary? What is the necessary infrastructure to, not only keep plants alive, but keep us alive as well? And so when we're talking about, water, one of the things that we're trying to, work on sort of, in the industry, in the space industry is, how do we recycle, or how do we reuse as much as we can, right? Because space sort of has this motivation, we're constrained by launch costs, right? And launch mass. But, and so we do have that natural constraint already, but, the more that we can reuse, obviously, these things start to become, okay, all of a sudden it can't be done to something that, okay, maybe this might work in the long term. So we tend to focus a lot on technologies that have that sort of recycling potential.
I mean,
to add on to echo what Stephen is saying, I like to remind people that I think space exploration and living in space is probably the biggest sustainability challenge you could imagine, because you are so limited on what you can carry with you, on how expensive it is to launch anything up there, and the amount of space you have. So it really pays off at some point to reuse and recycle anything that you can. And water is one of those very expensive resources in a spacecraft. So we have gotten pretty good, I would say pretty good, but we're not there yet, at recycling water. Probably maybe 85% of the water consumed is recycled on the space station. But yeah, the more we can show in this very difficult, challenging, resource constrained environment that we can be less earth reliant and more self-reliant, the more we can use those lessons here or anywhere for that matter, echoing Daniel's point. So we will always need water, but we can get better about using it more frugally and efficiently and recycling what we do use.
I think that's a really interesting way to phrase it, because I'm always thinking of terms of, square area and volume, right? There's all the arguments of how much area or volume do you need to grow food, right, sustainably? And, there's kind of the inversely proportional, how much energy you put into that system. So yeah, and even in agricultural systems, you look at like Japan, and it's how much energy per hectare goes into farming in Japan versus like Argentina. And the calories that come off that land or the food. So there's the intensification versus the extensification is what the term is called in agriculture, where you can use a lot of land in a very low intensity and passively get returns, right? Or you can have a very intensive. So it's very interesting. I've never looked at the metric around water. And okay, well, you need a half a hectare or a hectare to support one person's food consumption for calories, protein, and fats and stuff. What's the smallest volume of water you need for that? And I think some of that goes back to, a lot of the classics. I see Christine has the biosphere in the background there. A lot of it is, we view Earth as this, right, like closed ecological system. But there are a lot of losses to it. You have mineralization of elements and stuff. It's not, especially when you look at like entropy with these systems, entropy is still present here, right? So could we solve for $1 trillion bubble that could last for 1,000 years on the moon? Absolutely, but then it's a fixed rate. So what we're working on, to go back to the kind of what we're working on at Grow Mars, is how do you have an expanding loop process? Is how do you say, oh, we've started with one bubble, and actually this is reproducible in space. So we don't need additional hardware and stuff. We can go from 1 to 2 using in-space resources to do so, or on-site resources to do so in really a passive, reproducible way. And I think that's the metric for, do you have a sustainable space settlement? Could this go on for ever? Could you keep expanding at a rate of growth? And I teach a class on Mars agriculture, and I had to come up with a metric. Like, what's the point of this class, right? It's a 20-hour course, and I came up with a really basic assumption: is the human population on Earth grows at, on an annualized rate, 1.1% per year. So how do you expand your rate of production of oxygen, food, water? How do you expand your output capacity by 1.1% per year? If you can solve for that, you can solve for sustainable space development. And it's a rather small number, right? Oh, to grow a system by 1.1% a year, any business model, that would be like horrible, right? Rate of growth, you never survive. But it's a rather basic number. So you just need processes that can outpace that. And to the point of how much water you need, I think that's a really interesting metric, because then, okay, how much energy, how much hardware does it take to process that water back, or how much just passive ecological services can you integrate? Probably it's the same thing with land, the intensification versus extensification. You can use a lot of water passively, or you can use a small amount of water really intensely.
Interesting. Okay. And so it still feels like there's long tail challenges towards actually space farming, but growing plants in space is a doable thing. And so if we're not able to reproduce farm capable level food, right, is there ways that we can produce food or increase that scalably? Maybe if we take the plant out of it and start to think about other ways of feeding people. I don't know, this is just kind of me spitballing here, because any sort of long tail space travel now means that you have to send up every kilogram of food at through low Earth orbit, which is $10,000 a kilogram or whatever it is. and how many days is that person going to be gone for, times how many kilograms per day, is roughly how much it's going to cost to send that person. And so how do you feed people on long-term space travel without breaking the budget just on dehydrated ice cream like what we had in the 90s?
There have been a lot of white papers and analyses and studies to try to answer that very question of, and this gets back to the economic aspect, for creating, producing, growing your own food in space, as opposed to carrying your pre-packaged stored meals with you and carrying all of that. There is this idea that at some point there will be a payoff. At some point you'll be gone long enough, from enough days and far enough away from Earth that it'll become so expensive to carry all of your food that it will become more economical to bring all of the equipment you need to grow your food. But what you're alluding to, Daniel, is that you might not necessarily need to grow a plant. There might be other kinds of foods that ways that you can produce or create have a food system to create to meet your nutritional demands and needs for the crew while you're out there. There's a lot of work in artificial meat production, for example, like printing and culturing food from bacteria. There's a lot of interesting alternative crops and organisms that can be used for nutrition. But I would also caution that in the end, the only type of organism that is capable of producing organic material purely from energy right now is a plant, from energy and water and minerals, and turning that into an organic food product is a plant. They're autotrophic, and we are starting to figure out how to artificially create sugar, for example, without a plant doing it. But we're not that good at it yet, and plants are just better at it. They've been doing this for billions of years. So yeah, but at some point, the amount of energy and infrastructure and water you have to take with you to support this farm will pay off when you're out there long enough and far enough away from Earth. Now the question of when does that payoff happen? when does it become economically beneficial to do this rather than just carrying all your food? That's a question mark, and the target keeps moving depending on how expensive it is, launch costs and efficiency of technology. We're getting really good at lighting, for example. So it used to be really expensive to grow a plant because it's really expensive for electricity to provide the light to the plant. Really inefficient lamps, for example. And now we have LED lighting that can be used. And this is one of the great spinoffs, I think, from space ag into commercial indoor farming is the development of LEDs for plant growth systems that are energy efficient and now make this maybe more possible than it looked like it was 10, 20, 30 years ago.
Yeah. Go ahead.
What I'd add is, we talk a lot about launch costs and that being a constraint here. I think when we when we unshackle ourselves from that, everything changes. So so if you say it costs, I think you said 10,000, I think it's more than that, but whatever it is, whatever the number is, as long as we're looking at our business as a function of cost, I would even take it a step further as a function of revenue or profit, we're missing the venture possibility here. When we start thinking of it in terms of value creation, it's completely different. I'll give you a simple example. I want a different type of farming, server farms, not plant-based farms, but I'll bring it back to agriculture farms in a second. Server farms, computers go up, they create data centers, right? And let's just say there's a need for cloud computing in space, or for whatever reason, companies want to do it. And cloud contracts are gigantic, by the way. The Fortune 100, Global 1000 spend billions and billions of dollars a year with Amazon, Google, Microsoft, but also on-premise. So it's a huge industry. The cloud market is growing faster than all the largest cloud providers combined, how fast they're growing. So in that sense, when you're thinking about a server, and sending that computer up to space for a data center in space, you can talk about cost per kilogram of the computer. But if I know that that computer is going to generate $1 billion of value for me because it's going to get that contract, I don't really care if launch costs $200 million, $100 million, $20 million. Like, I just know it's creating $1 billion of enterprise value for my company. So bringing this back to regular farms, once we figure out, I won't just say the model, but it's something Daniel said also. I think he used, imagine we spent $1 trillion for this gigantic farm on Mars, and it was worth it for us because we decided it was worth it. Great. But if that could solve another problem where it itself could spawn other farms from there, and we know it could go forever. And I love that thinking. Already you've brought that cost down to zero, right? Like it's gonna now add a little layer of value. And I made up this example of this amazing tasting tomato that for some reason makes, you send it back to Earth and it creates all this value, or whatever our civilization is on these other planets or in orbit love this tomato, and it's making so much money. We'll send up farms regardless of the launch cost because this tomato creates so much value. Now, I'm using this example of a super well-tasting tomato, but really it's about sustaining our species, right? We need that food, survival. There probably isn't anything more valuable than our food and our water, of course, but in those first stages of survival off planet.
That's super interesting. I think just a quick aside on the economics of industrial space, right? That's something that's different, right? If you're supporting people in industrial space, building structures, there's different opportunities there. But Andy Weir, who wrote The Martian and Project Hail Mary, and a book called Artemis in between those two that didn't get as much press, wrote a really interesting economic thesis about what it would take to develop industries on the moon and in space. And one of the theses was zero attenuation fiber optics, like actually thinking about doing manufacturing of fiber optic cable in zero gravity makes the fiber optics better. And so that they're able to transmit data incrementally more efficiently. And so I think in thinking like this, maybe to Daniel's point when he said earlier, is really have to unthink about some of the current traditional opportunities and think about some of these different ways that if industry opens up in space, people need to go there to build these things, and food then becomes a real issue. I think, Daniel, we were on the conversation where someone said that they wanted to sell the first salad in space, or we knew, and so I guess the industry, everything kind of works together to lift all of those rocket ships into a different type of operation.
Yeah, I just want to say a couple points. So back to what Christine was saying, one thing that also we have to think about when we're, talking about alternative sources of, protein, calories, and whatnot is the palatability of the food, right? So there's been a lot of studies at NASA and, other organizations about, just because we can grow these types of foods, does it mean that the astronauts will like it? And we don't really think about it here on Earth a lot, but, food affects our mood a lot. And so especially if you're, in a very constrained, very closed space environment, you really want to, keep up that mood, sort of that atmosphere in your system, and that camaraderie between the people. And, what better way to do that than food? Another thing that I wanted to mention with Tej's thing is, and sort of, I think he alluded to it as well, is this idea of equivalent systems mass. So this is the sort of official metric that people in the industry use that also, will account for things like, the profitability of these sorts of things, but also the value that they add, that sort of non-tangible value that they add to a particular space mission or whatnot. And so NASA is actually looking at, sort of updating a lot of these older metrics. That's actually something that I'll be working on this summer at Johnson is, answering these sorts of trade study questions on, is it better to bring plants? Is it better to, grow our own food there? And, what is that trade-off point? At what, mission length does that actually pay off?
I've got, that was a great question, Daniel. So I gotta chime in there too on the food side, especially the cell-based food and synthetic sugars and such. Well, I guess to take it a step back further, right? The way that we look at food at Grow Mars is you have 4 options. You can bring your food, you can bring your greenhouses, whether they're passively lit or LED lit. You can bring the machine to make your greenhouses, or you can bring a machine that makes greenhouses exponentially. So we're working on the 4th one, is how do you bring a machine that makes greenhouses exponentially? So really, those are really your 4 limited options. Now, looking at the different techniques, right? The Goldilocks situation is you have cold fusion, you have synthetic production of sugars, and you're feeding those to microbial vats to produce your proteins and your sugars. That's all electrically constrained. And I have a unique position in that, being a plant pathologist, we grow lots for disease studies. We do lots of culturing. And I'll tell you, I'd rather work out in the field than work in the lab doing all that culturing. As you think, oh, microbes are pretty easily, you can get contamination, all those problems you have at the macro level, you actually still have at the micro level. So you still have a lot of hardware, you still have a lot of manual labor working in the lab-based settings with microorganisms. Still takes a lot of energy. Ultimately, for those systems, you still need things like fertilizer. When you mix up, a gel plate, you still need ammonium sulfate. You still need, okay, where are you going to get this ammonium sulfate for? You don't think of like, oh, you need fertilizer. It doesn't break you away from the fertilizer chain totally. So the one thing that plants are really good at. So yeah, if you're electrically constrained, go cell-based, right? You can do synthetic sugar production. You can do LEDs to algae. That's going to be the most efficient system from an electrical standpoint. Where biology stands out is that it's not electrically constrained and it's self-replicating. So all that lab-based system, you have to figure out how to make all that lab hardware again. How do I make another bioreactor for this? How do you make another centrifuge? All the lab hardware equipment that you need to make that cell-based food system work, you have to figure out how to make that hardware again. Whereas in a plant-based system, that seed is going to grow and produce another seed, right? Or that cell is going to grow, even if it's passively lit algae. That biology is self-replicating by nature, and it is self-maintaining. What plants are really good at in the space realm is doing things like extraction, right? Is their roots will actually exude acids and stuff to do mineralization and actually harvest those essential elements. You're still going to need nitrogen, phosphorus, potassium, all these building blocks of life, same thing that the cells need and our bodies need. Where are you going to get these elements from, and how are you going to sort them all through to what supports life? Is roots, algae isn't going to necessarily do that as well as like a higher plant. So when you go to like regolith-based farming, higher plants have a really specific function, like from an extraction and processing and purifying. So that's just kind of a spectrum from cold fusion and synthetic sugar production all the way through kind of all those intermediates where it's kind of hybrid systems to, okay, like a pure seed and soil based system and some of the advantages and disadvantages. Plastics is interesting because it's also not electrically constrained. So when you do bioplastic polymer production, it's almost entirely thermally driven. So we're one of the top 108 carbon. So we're in the X Prize Carbon Removal Challenge, one of the top 108 qualified teams for doing gigaton scale carbon removal by having a positive feedback loop system around bioplastic, is where you can use passive solar thermal at scale to do your processing of that biology into useful output. Is our carbon sink is literally clear plastic that we can grow more biology in passively under the sunlight. So you're kind of less electrically constrained if you think of more traditional biological systems.
That's awesome. We got some great audience questions, and so we have about 20 minutes left. And so let's kick it over to the audience, and then we're going to wrap it up with each panelist and a few other lightning round questions that I have for everybody. The first one's from Victoria DeLeo. And she says, you've talked about closed loop systems and extreme resource limitation in space. Are there any resources that we would expect to be more available in space? Maybe in higher light intensities, rare materials, or anything else that would be beneficial?
So there's this really cool experiment that was on, I believe, the Mars rover. It's MOXIE. I'm not sure if anyone's familiar, but it's this idea that you can sort of sort of what Daniel Tompkins was alluding to about using, the resources we have and sort of, changing them into things that we need, right? So this one, I believe, will change something in the Martian regolith to provide us with hydrogen and oxygen, right? So things like that, if we can sort of scale these technologies, I see that as, something that we can use there. Maybe not necessarily in, higher quantities that, that are present on Earth, but these sorts of things can actually really help us, sort of alleviate all the material that we need to bring from Earth.
Anyone else?
I think also, there has been an increasing level of interest in things like space mining and the potential that there could be valuable minerals that we could go get from asteroids or from the moon. I am not an expert or a mineralogist or anything like that to be able to tell you more about specific resources, but that is a potential industry that would warrant, building these kinds of systems and capabilities and infrastructure to have a settlement where maybe it does become a benefit to be able to go get some of these minerals and mine resources that are of limited availability on our planet.
I know that was the mission of Planetary Resources, which was a really cool startup a few years back. I think it ended up getting sold to a Bitcoin company, if I'm not mistaken. I think Convene ended up buying that. I'm not sure. But I guess space mining is another one of those challenges where if you're going to be on a place, you need to figure out a way to extract the resources. Thank you, Victoria. That's a great question. Are there any another Victoria question, are there any other uses of space ag beyond food? Is there anything in industrial biomanufacturing, molecular farming, anything else interesting going on that zero orbit could be a industry source for?
So not sure if it directly applies to the end of that question, but we are working on carbon capture and sequestration. How do you energetically fix a whole bunch of carbon or make a lot of carbon negative infrastructure? That kind of plays into it if you're looking at it from an infrastructure standpoint. Going back to that other question, what resources are abundant? Higher light intensity, but also more predictable light intensity. So when you have cloud cover and then you have high intensity sunlight, those changes in light kind of make for an inefficient photosynthetics situation. So you really have both higher light intensity, but also more predictable conditions. As you know, it's always cold. Like there's not really a space weather component here. You don't have to worry about a cloudy day necessarily. Of course, there's dust storms on Mars and such. And as far as, let's see, let me go back to the answered question here.
Except for maybe unpredictable radiation, but that's another story.
Okay.
Solar radiation storms.
So beyond food uses, clothing as well. So really, if you look at through the spectrum of a post-oil world, how do we derive all of our products that we derive currently from petroleum distillates, which you've got to remember is really just old biomass, is you can pretty much derive any chemical that's currently derived from oil from biomass. It just takes additional steps in distillation. So you can make anything in space. You don't need oil. Again, oil is just really old biomass. There's nothing magical about it. So how do you do that all energetically and efficiently? That's a great question. So off of the food, right, is we don't really think of like petroleum-based distillates as being agriculturally based, but in space they are by default. All the organic chemicals.
Of course, that leads us to biofuel, all of those pharmaceuticals. We could make medicines. Would it be more beneficial to make them in microgravity? We don't really know the answers to those questions. Like Tej was saying, we don't necessarily know what we're going to learn about the benefits of potential benefits of the space environment on these processes that maybe could be more efficient for certain products you might be developing. But in general, if you're learning how to produce anything you need, clothes, fuel, polymers, fibers, medicines, if you can continuously regenerably produce these things that you consume and need to live in this constrained environment, then we can, well, basically we can do that anywhere. So it's the challenge in of itself, I think, that reaps its own reward.
Yeah, another thing to keep in mind is, even if the intention is just to generate food, given all the constraints we have to deal with going up there, including the economic constraints right now with physical space and waste. There's, Christine mentioned efficiency. There's just a lot of effort put into not wasting anything up there and using outputs that maybe down here we wouldn't even consider, whether that be gas or whether that be extra materials or whatever. I wouldn't be surprised if you start seeing alternative uses for excess that comes out of anything we might be developing up there. And I've already seen it. Again, I'm not a scientist, but a lot of startups come my way, and I've seen quite a few non-plant-based food companies that use some sort of bacteria or something that they develop, something that provides a protein type output that can feed astronauts, and it sort of tastes okay. But what you find with a lot of these companies, they're using different gases, or that bacteria is producing a different gas, which might be better or different, but there's alternative uses for those gases that normally we wouldn't have come by if we weren't trying to solve for these problems.
And I think if space farming is largely plant-based, right, there's all the inedible portions of that crop that you can synthesize into all these other streams as well. So as much as a large, it's almost, you have to think of the waste solution in tangent with your production system. So once you have a really, highly productive system, okay, what do you do with all these other quote unquote waste streams, right? What do you do with all these other waste streams? And it's kind of like, stairs of entropy, right? As plants kind of quickly bring it all up, and yeah, you harvest some of the fruits and vegetables off the top, but then you still have this huge gap of essentially, embodied energy into the molecules that are there that you can then extract different resources from.
Cool. That's awesome. And then one more question from the audience, then we're going to do a quick rapid fire lightning round. And so the question is from Henry, and it's kind of two parts. It's what will the role of computation, modeling, and AI be in the future of space farming? And what data do you need to see from today to make better assessments of what the potential is in the future, right? So what do you need to see that you're looking for to help you make these longer term decisions? I think that's kind of the goal of the question.
Yeah, I can start with this. As with any other industry, for us, data is really, really important. One of the key parts actually to my PhD thesis is using different hyperspectral imaging techniques, different sorts of, automated sensing techniques to actually be able to grow these plants autonomously in space. And so, that's definitely going to be really important, especially as we move, to the moon and to Mars, where, some of these astronauts, they're really having to, worry about much, other types of maintenance tasks. And, while they do enjoy growing plants and things like that, if they can, sort of redirect their energies towards something else, that's always a good thing. And just adding on to that, Chris and I actually worked on a white paper a while back on actually this specific topic. We got some people from industry, from NASA, from all these different types of organizations to chime in and sort of speak to this. Chris, you want to add a little more on that?
Yeah, so as Stephen was saying, we did a white paper on some of the knowledge gaps and needs for applying AI, and I would say AI and robotics to growing plants in space. And one really simple way to look at it is that in space, like we've talked about these constrained resources, human labor And human brain power is also a really limited resource, right? You don't have masses of people to operate and run a farm. So how do you most efficiently use the brain power you have available and the manpower that you have available? And so that's where AI and robotics really comes in. And there's so many ways that industry and that field of technology can be applied, anywhere from helping to process massive amounts of data, like Stephen was mentioning, hyperspectral data, for example, to correlate, say, certain colors that are reflected back in an image with a certain piece of information, like the fact that the plant may be water stressed, and then to decide an action based on that image. Now I need to go water the plants. So being able to use AI and machine learning to basically mine massive amounts of data to learn correlations between a certain sensor reading and a certain state of the crop or plant, and also be able to choose or decide a correct action to take, to be able to monitor their health, to figure out optimal growing conditions that maximize not just how much you're growing, but what the quality of the biomass is, figure out what's the best lighting, what's the best temperature, photo periods, all of those different things to get the most nutrition packed crop that you can get. So you can optimize, you can monitor health, you can mitigate, detect when you're having a problem or a failure. And then we have labor. So that's the cognition part, right? The thinking part. Can we teach a computer to figure out how to make the decisions we would make as a gardener or a horticulturist and think like we do? Can we provide that knowledge, or can the AI help us maybe even gain knowledge we didn't have and apply it? But then this is a whole nother area, is robotics, which there's been really great strides in use of robotics and machinery in terrestrial agriculture to reduce human labor that you need to till, to seed, to harvest, to prune, to do all of those things that you need to physically manipulate the plants to produce your crop and harvest your crop.
And that's well, I hate to cut you off there, but that's what we've been talking about at NYC AgTech Week. Every panel, data, AI, and automation comes up, and its role in how does technology augment, replace, help, assist, whatever the right word is. Technology's role in these systems is ever changing, and it feels like, to me, the changes are exponential, because we're talking about really science fiction. We're talking about actually growing plants that have spent billions of years evolving on Earth to our unique conditions to thrive and survive in soil, on land, on Earth. And we're doing something completely unique, and that's pretty cool.
And real quick, if you have a big robot tiller on Mars, right? Now you've got the challenge of you need to make it real small so that you can carry it, because it's got to fit in this small spacecraft. And you got to make it rugged so it doesn't break down on you while it's out there and be able to survive.
And you need people to fix it, and that's where a lot of these challenges really multiply. And we definitely could talk about this all day. Anyone in the audience, I encourage you, we'll provide some resources to hopefully reach out to folks. But I have a couple quick questions that I want to ask everybody in a lightning round, and then everyone's going to get a quick soundbite for next steps. And the first one is, we'll keep it light. Favorite science fiction show or inspiration?
Let you guys go first. Lightning round for me, Star Trek Next Generation, hands down.
Perfect.
Dune and the Three-Body Problem for me.
Ooh.
Ender's Game.
Nice.
Tej?
Black Mirror.
Okay. For me, my background, for those who haven't known, is The Expanse. That was my, it's epic. It's awesome. All right. Where do you think the first space farm is going to be? In orbit, on the moon, or on Mars?
In orbit.
In orbit, possibly around the moon.
Ooh.
Yeah, we'll see. We'll see. Some of the commercial space station programs, and I guess NASA's Gateway. Of course, Russia and China are also doing some other really interesting things. So it's an exciting time for us.
Okay.
The first reproducible farm, so the first farm that multiplies, I think, will be on Mars, mostly because it has nitrogen.
And everyone should read Daniel's paper about that. The next two are via Brian M, who asked us in chat, is most overhyped and underhyped technology that you've seen in space or space farming.
That's a tough one.
Yeah.
I'm gonna go out on a limb and since we work on plastic houses, I guess I can throw rocks, not in a glass house. I think glass domes, are not feasible. I think the dome-based architecture, there's been a lot of NASA or in association with NASA papers on why domes are just not good structures on Earth or in space. So I'm gonna.
We should talk about that, Daniel.
I will say underhyped, definitely the irrigation systems.
Yeah.
There's been a lot of work being done on irrigation, really, ingenious designs. And, just to actually get water to plants in a way that, provides them enough water, but also doesn't flood the roots is just, such a technical problem, but very, very, very much needed.
Yeah, for me, this is hard. Overhyped, I don't know. Underhyped, I would say, just from my experience with what I've seen our engineering team and when they're building Axiom Station, there's a lot of traditional technology or just kind of like stuff you get at Home Depot that probably wasn't allowed on ISS that a lot of commercial companies can use that don't impact. It's not cutting corners. They don't impact security or safety, but certain problems, whether it's about air filtration, water recirculation, like that I've seen just in our habitat, that a bunch of smart people sitting in a room solving with certain constraints lifted, just have created very elegant and likely intellectual property creating solutions that I don't think would have come through the space industry before.
Awesome.
I agree with Stephen on underhyped is irrigation, anything that's collecting and transporting and distributing water in a small space, but also staging, ways of spacing and moving crops around so that you can get the most growth in a small area is kind of underhyped and underappreciated, the mechanical challenges.
Awesome. And then last one. Will a human step foot on Mars before 2030? Yay or nay?
Not their actual foot.
Okay.
Good answer.
Okay.
It's really cold, baby, to get frostbite. So
No.
maybe a greenhouse. We got to have the greenhouses built
Right,
first
okay.
before they actually step foot on Martian regoliths. So we got to have greenhouses first.
I'm going to say it's very, very possible because I think there is a growing passion and drive to go and
Cool.
to explore. And with that passion and that drive and that combined vision, really anything's possible. And yeah, we can get there. It's only us standing in our own way.
Yep. Never, they say in finance, never underestimate compounding interest. And, there's in a different way, different types of interests, that are compounding in this space. And so, it just takes, a bunch of champions to sort of get us there.
Awesome. Well, I know that we're running, we have a hard stop at 1 o'clock, and I just want to give everybody a sincere thank you on behalf of myself and the rest of the Ag Collective. This is a volunteer-run nonprofit organization in New York. We're trying to recreate community and conversations around everything from urban agriculture and sustainability to farming and more. And so thank you for joining. We have a couple more conversations today. Next is on alternatives. We're going to be talking about duckweed, mushrooms, and algae growth, spirulina. And so with that, I'm going to give everybody a chance to guide one final sound bite. We're going to start with Tej, just because I know he's got to jump.
Yeah, so I want to, I know we're talking about farming, this is a little different. We just announced a relationship with a champagne company called GH Mum, part of the Pernod Ricard family. And the amount of agriculture and farming that has to go into creating champagne is pretty insane. There was a couple of really nice comments that came out of the Pernod Ricard folks. One is, and I'll just leave us with these two comments. One is you can't take humanity to space if you only take humans. So when we're talking about food, it's not just sustenance, it's our culture, it's who we are as a species, and that's important when we go out there. And the second is all of our jobs is to make what's seemingly simple here possible up there. So this is not any small feat that anyone is working on to try to grow food up there. It's extremely important, extremely complicated. So I applaud everyone, and Dan, thanks for setting up this call.
Yeah, thank you so much for joining.
Yeah.
Christine, why don't you just give final soundbite if anyone wants to find out more or connect or anything else?
Two things. One, I don't want to end on a bummer, so I'll say it first. The space is hard. So we talk about how great this idea is, but if you're going to get into this field, be prepared that the technological challenges are big, and it's going to be a long journey, and we really need to prove out all of these things in a very harsh environment before we can really be successful at it. So you've got to stick to it, have some engineering integrity, do things well, test them out, make sure it's going to work. Space is not easy, but also it's well worth the journey. And like Tej said, we really aren't going by ourselves, and if we take our gardens with us, we're taking a little bit of home with us, and it'll be well worth the journey.
Daniel?
Sure. So I'll follow that up with a lot of the assumptions of growing plants in space are typically wrong, or there's actually opportunities that go along with them. So as much as there are challenges, there are opportunities actually where plants can grow better in space, for some of the comments made today. And another one is that plants are hardy, is that we're designing systems that are plant-rated habitats, right? That are not human-rated habitats. And if you think of it like that, plants are much easier to keep alive in space than humans are. So, and especially the risks to mitigate and stuff. So think plant habitats and really question your assumptions around, are these, a lot of the assumptions of growing plants within this context.
I guess I'll wrap up here. So I guess my big message to the AgTech community is, don't be afraid to share your data. I think, we go much farther together, and a lot of the insights that would be garnered from AI, from machine learning, you can't get simply by just, your organization alone. It really takes a ton of experiments, a lot of different settings for those experiments to really, bring together the insights that we need, not only to grow plants on Earth, but in space. So yeah, that's what I'll share.
Well said, Stephen.
Thank you all so much. It was such an honor to share this with you. I really, really valued this conversation. We're going to have so much more from here because there's so many good sound bites. Please stay in touch. Audience members, we will provide some more info if you guys want to reach out to them. But thank you again. Thank you for coming to AgTech Week, and we'll see you at the next one.
Thanks, Dan.
Bye-bye.